All right, let's get right into it. When you hear the word metaverse, you're probably picturing, avatars and cool 3D spaces. But what if the most important part, the real magic, isn't what you see on screen, but the invisible rules that hold it all together? Today, we're digging into the Metaverse Build Runtime, a project that sees itself less as another platform and more like a fundamental operating system, but for virtual worlds. And they start out with this really bold claim that most of the virtual worlds we're using today, they're basically built on sand. They have these deep architectural flaws that make them unstable, unpredictable, and ultimately just not reliable. That's a pretty strong way to kick things off, right?
So what is this problem they're talking about? Let's actually break down the specific issues that seem to plague so many of these really complex digital environments. Okay, so what exactly are these broken foundations? Well, it usually comes down to these four things. And they're all connected. First, you get authority leaks. Sounds bad, right? It means the rules about who can change what are flimsy or, worse, can be bypassed. This mess leads to what's called implicit state. Basically, the system's history is a total black box. You can't ever truly reproduce what happened. And that, of course, causes non-deterministic behavior. You could replay the exact same events 100 times and get a different result. And to top it all off, no real audit trail. So there's no trustworthy record of who did what, when. It's just a recipe for digital chaos.
So to fix this, you can't just slap a patch on it. You've got to go way deeper. The whole approach here is to introduce a brand new, fundamental rule for how this digital reality is allowed to operate. And that all starts by changing what this project even is. See, it's not a game engine or some social app loaded with features. It's a capability kernel. The best way to think about it is like the laws of physics for a new universe. It doesn't create the planets or the stars, but it absolutely enforces the non-negotiable rules that everything else has to obey. And this right here, this is that law of physics. They call it the core invariant. Every single thing, every action in the entire system has to follow this four-step flow, no exceptions. First, you establish identity. Who is trying to do this? Second, you check authority. Okay, are they allowed to do it? And only if the answer is yes, do you create a trace, which is an unchangeable record of that valid action. And then finally, you create a projection, which is the thing users actually see or interact with. Identity, authority, trace, projection. It's a chain that cannot be broken. So how in the world do you enforce a rule that powerful? Well, you need a totally uncompromising, absolutely unblinking gatekeeper right at the very heart of the system. And here it is, the authority gate. It's a module written in Haskell, and for good reason. Haskell is a programming language known for being incredibly strict, almost mathematical, which is perfect for building systems where being correct isn't just a feature, it's everything. And its only job is to check permissions. Before any change to the world is even thought about, it has to get past this gate. No backdoors, no special passes. The project's own documentation just says it perfectly. This isn't some handy little tool or some piece of middleware. It is positioned as the absolute judge of what is and is not possible inside its digital universe. It is the gatekeeper of its reality. And this just lays it out so clearly, the massive difference it makes. Without the gate, you get that chaos we were talking about before. But with the gate, everything is orderly. Your identity is validated, permissions are checked, and this is the crucial part, if there's any violation, the system doesn't just show you an error message. It halts. It just comes to a dead stop. This is what they call the safety contract, and it is absolute. If a rule is broken, the process halts instantly. It emits 0 bytes of data. Nothing gets out, and everything downstream of that process remains completely unchanged. And this isn't some feature you can accidentally turn off. This is enforced at the kernel level, the very core of the whole system. This super strict enforcement leads to a really powerful architectural idea. This clean, beautiful separation between the source of truth and the things that are just looking at that truth. It's a philosophy they call the kernel reconstruction doctrine. So instead of trying to patch up old, messy projects and carry all their baggage and flaws forward, this system rebuilds everything from first principles. Old code is treated like an archaeological site. It's super interesting, you can learn a lot from it, but you would never, ever build your new skyscraper on top of ancient ruins. So this is the most crucial point to get. There's this massive divide. Upstream, you have the authoritative kernel. This is the source of truth, it's the spine of the entire system, it holds the world state, it enforces all those rules. Then downstream, you have projections. These are things like your 3D graphics, the user interface, maybe some data reports. They have zero authority. None. They're just disposable, rebuildable windows looking at the upstream truth. So if your UI crashes, who cares? You just restart it. The truth back in the kernel is still safe, completely untouched. Okay, so we've got this incredibly robust, super secure foundation. But why does it matter? What's the point? Let's talk about the new possibilities this kind of architecture actually creates.
Well, for starters, this isn't just a theory on a whiteboard. The project has actually verified 100% deterministic replay across more than 35 major development phases. That means they can rewind the tape and get the exact same result every single time. That's a level of reliability that most complex software systems can only dream about.
And that reliability unlocks some really powerful applications. For multiplayer games, you get perfect deterministic state sync without all that complicated networking code. For virtual worlds, you can have genuinely enforceable property rights because that authority gate will not let anyone steal or change what isn't theirs. You can run scientific simulations that are 100% reproducible, build audit systems with a complete and tamper-proof history, and even have tiny little embedded devices act as totally secure endpoints.
So it really all comes back to this. By focusing on a foundation of simple, unbreakable rules, you create a platform to build more complex, more reliable, and frankly more fair digital experiences than we've ever been able to before. And it leaves you with a really fascinating question. If you had a blank slate and you could create a world with rules that could never, ever be broken, what would you build?